Hey everyone, let's take a look at number 16 in section 2.3. We're going to evaluate the limit here, assuming that the limit as x approaches -3 of f of x is 2, and the limit as x approaches -3 of g of x is 5. Again, we're going to use the basic limit laws. So here I have a limit of a quotient, right? One function divided by another. So I'm going to write that as the limit. I don't know why I have this extra parentheses here. I don't know why I did that. Sorry. Just as 4 times g of x. But it's the limit of this whole thing, right? Limit as x approaches -3 at the top over limit as x approaches 3 at the bottom. That's the first basic limit law. And then up top, I've got the limit of a sum of two functions. So that's the sum of the limits, provided these limits exist. And then this is the difference of two functions. So the limit of the difference is the difference of the limits, right? So this is a basic limit law here as well. And then I'll just, instead of rewriting the whole thing, I'll just say, well, the limit as x approaches -3 of a constant times g of x, right? This constant can come out in front times this limit, again, provided this limit exists. Okay, so I can only do what I've just done going from here to here if each of these limits exist. Well, do they? Well, this one obviously does, because limit as x approaches -3 of 1 is just 1 because 1's a constant. And the limit as x approaches -3 of 9 is just 9, right? 1 and 9. What's the limit as x approaches -3 of f of x? Well, we're told that that is indeed 2, right? So I'm just going to replace that whole expression with 2. And then what's the limit as x approaches -3 of g of x? Well, that's 5. And I can plug that in. And now I just do the math, and there's my limit. And that's how you use basic limit laws to find the value of the limit of our original expression here. Hope this is helpful.